classmates and mom. Do you have any guess what is our topic in this video? Great guess! It's electromagnetic waves. Did you know? Electromagnetic waves can be classified in two types. The first one is low-frequency waves. It includes radio waves, microwaves, infrared rays, and visible light. And the second one is high-frequency waves, and it includes UV rays, X-rays, and gamma rays. Maybe not all of us know that these electromagnetic waves are very useful to our everyday lives. But say less. Here are the group 2 to help you learn more about our topic.
Electromagnetic waves are formed when an electric field, which is shown in red arrows, couples with a magnetic field, which is shown in blue arrows. Magnetic and electric fields of an electromagnetic waves are perpendicular to each other and to the direction of the wave. Electromagnetic waves consist of two waves oscillating perpendicular to each other. One is the oscillating electric field, and the other one is an oscillating magnetic field. The direction of propagation of the wave is perpendicular to the electric field and the magnetic field.
Radio is a sound communication. It can travel long distances through obstacles. This is the reason radio waves are used for communication. The word radio originates from the Latin radius, meaning ray or beam. A radio sends the electric signal through speakers so the sound can be heard. Radio is discovered by Heinrich Rudolf Hertz. He was born in 1857 in Hamburg. Radio waves have the longest wavelengths in the electromagnetic spectrum. They range from the length of a football to larger than our planet. Heinrich Hertz proved the existence of radio waves in the late 1880s. He used a spark gap attached to an induction coil and a separate spark gap on a receiving antenna. When waves created by the spark of the coil transmitter were picked up by the receiving antenna, sparks would jump its gap as well. Hertz showed in his experiments that these signals possessed all the properties of electromagnetic waves. Radio waves composes. Radio waves are produced artificially by time-varying electric currents, consisting of electrons flowing back and forth in a specially shaped metal conductor called antenna. Radio waves are a type of electromagnetic radiation with the longest wavelengths in the electromagnetic spectrum, typically with frequencies of 300 GHz and below. Radio waves are generated artificially by an electronic device called a transmitter, which is connected to an antenna, which radiates the waves. They are received by another antenna connected to a radio receiver, which processes the received signal. Radio waves are very widely used in modern technology for fixed and mobile radio communication, broadcasting, radar, and radio navigation system, communication satellites, wireless computers, networks, and many other applications.
What is X-ray? X-rays are a form of electromagnetic radiation,
The users of X-ray mainly used to look at the bones and joints, although they are sometimes used to detect problems affecting soft tissue, such as internal organs. Problems that may be detected during an X-ray includes bone fractures and breaks, tooth problems such as loose teeth and dental abscesses. What are the 10 uses of X-ray based on my research? First, medical imaging. Second, security or airport security. Third, radiation therapy. Fourth, industries. Fifth, astronomy. Sixth, engineering applications. Seventh, restoration. Eighth, medical science. Ninth, criminal investigation centers. And lastly, crystallography. Functions. X-rays produce images of internal tissues, bones and organs on film or digital media. X-ray imaging tests are painless procedures that allows doctors to diagnose diseases and injuries without being invasive. Because X-ray commonly used when there is something that the person does not immediately determine. X-ray were discovered in 1895 by German physicist Wilhelm Conrad Röntgen, born on March 27, 1845. While investigating the effects of electron beams, then called cathode rays in electrical discharges through low-pressure gases, Röntgen's discovery occurred accidentally in his Würzburg, Germany lab, where he was testing whether cathode rays could pass through glass when he noticed a glow coming from a nearby chemically coated screen. He dubbed the rays that caused this glow X-ray because of their unknown nature. Röntgen uncovered a startling effect, namely that the screen coated with a fluorescent material placed outside a discharge tube would glow even when it was shielded from the direct visible and ultraviolet light in the gaseous discharge. Röntgen was able to show that the radiation responsible for the fluorescence originated from the point. Composes. An X-ray is a packet of electromagnetic energy that originate from the electron cloud of an atom. This is generally caused by energy changes in an electron, which moves from a higher energy level to a lower one, causing the excess energy to be released.
Visible light. Visible light is a type of electromagnetic radiation which is transmitted in waves or particles at the different wavelengths and frequencies. This broad range of wavelengths is known as the electromagnetic spectrum. The spectrum is typically divided into 7 regions in order of decreasing wavelengths and increasing energy and frequency. Perhaps the most important characteristic of visible light is color. Color is both an inherent property of light and artifact of the cell in the human eye. Visible light is extremely important to humans. We use it to see. Without light, our eyes would not be able to see images of anything. Aside from sight, they are important uses for visible light. We concentrate visible light to make lasers to use everything from surgery to CD players and to laser pointers. Visible light waves also make our TV and computer and cell phone screens work. Visible light spectrum was discovered by Isaac Newton in 17th century, although there is further knowledge that it had been discovered 4 centuries earlier in the 13th century by Roger Bacon. In 1665, Isaac Newton, then a young scientist at Cambridge University in England, took a glass prism and held it up to a beam of sunlight streaming through the window. He saw the sunlight that passed through the prism spread out into the color of the rainbow. The color of the rainbow is red, orange, yellow, green, blue, and violet. Visible light is composed by photons and different wavelengths ranging from about 400 to 700 nanometers. Each of these wavelengths correspond to a distinct color. The longest wavelengths of visible light are perceived as the red light and the shortest as violet light. A photon is an elementary particle that is a quantum of the electromagnetic field, including electromagnetic radiation such as light and radio waves and the force carrier for the electromagnetic force.
UV rays. Ultraviolet or UV radiation is a form of non-ionizing radiation that is emitted by the sun and artificial sources, such as tanning beds. While it has some benefits for people, including the creation of vitamin D, it also can cause health risks. Our natural resources of UV radiation is the sun. Ultraviolet means beyond violet, from Latin ultra, beyond. Violet being the color of the highest frequencies of visible light, ultraviolet has a higher frequency, thus a shorter wavelength than violet light.
UV radiation is widely used in industrial processes and in medical and dental practices for a variety of purposes, such as killing bacteria, creating fluorescent effects, curing inks and resins, phototherapy, and sun tanning. The UV rays are discovered by Johann Wilhelm Ritter. Ultraviolet radiation covers the wavelength range of 100 to 400 nm, which is a higher frequency and lower wavelength than visible light. UV radiation comes naturally from the sun, but it can also be created by artificial sources used in industry, commerce, and recreation. The UV region covers the wavelength range 100 to 400 nm is divided into the three bands UVA 315 to 400 nm, UVB 280 to 315 nm, UVC 100 to 280 nm. As sunlight passes through the atmosphere, all UVC and approximately 90% of UVB radiation is absorbed by ozone water vapor, oxygen, and carbon dioxide. UVA radiation is less affected by the atmosphere. Therefore, the UV radiation reaching the Earth's surface is largely composed of UVA with a small UVB component. The amount of UV radiation from the sun that hits the Earth's surface depends on several factors, including the sun's height in the sky, latitude, cloud cover, altitude, the thickness of the ozone layer, and ground reflection. Reductions in the ozone layer due to human-created pollution increase the amount of UVA and UVB that reaches the surface. These can impact human health, animals, marine organisms, and plant life. In humans, increased UV exposure can cause skin cancers, cataracts, and immune system damage.
Next is gamma ray. A gamma ray is electromagnetic radiation of the shortest wavelength and highest energy. Gamma ray radiation has wavelengths generally smaller than a few tenths of an angstrom, up to 10 to 10 meter, and gamma ray protons have energies greater than tens of thousands of electron volts. A gamma ray, also known as gamma radiation, is a penetrating form of electromagnetic radiation arising from the radioactive decay of atomic nuclei. It consists of the shortest wavelength electromagnetic waves, typically shorter than those of X-rays. Uses of gamma rays. Gamma rays are used in medicine like radiotherapy, industry, sterilization and disinfection, and the nuclear industry. Gamma rays are also used for sterilization of medical equipment. Gamma rays easily pass through the packaging of medical equipment and can only be stopped by thick lid. and kill living tissues such as viruses and bacteria. Gamma rays can be produced by several processes that are both nuclear and non-nuclear. Uses of gamma rays: sterilize medical equipment, sterilize food like irradiated food, uses as tracers in medicine, radiotherapy, in oncology to kill cancerous cells, gamma rays astronomy. Functions of gamma rays: X-rays, gamma rays, and other forms of ionizing radiation are an effective way to treat some types of cancer. During radiation therapy, high doses of ionizing radiation, much higher than those used for imaging tests, are directed at the cancer, resulting in the death of the cancer cells. Gamma rays from space are absorbed by Earth's atmosphere. They can destroy living cells, produce mutations, and cause cancer. Ironically, the deadly effects of gamma rays can be used to treat cancer. In this type of treatment, a medical device sends out focused gamma rays that target cancerous cells. Discovery of gamma rays. Gamma rays were first observed in 1900 by the French chemist Paul Billiard when he was investigating radiation from radium. They are emitted by a nucleus in an excited state. The emission of gamma rays does not alter the number of protons or neutrons in the nucleus. The term gamma ray was coined by British physicist Ernest Rutherford in 1903, following early studies of the emission of radioactive nuclei. French chemist Paul Billiard first identified gamma rays in 1900 from the element radium, which had been isolated by Marie and Pierre Curie just 2 years before. Composes of gamma rays. Gamma rays are weightless packets of energy called photons, unlike alpha and beta particles, which have both energy and mass. Gamma rays are pure energy. Gamma rays are similar to visible light, but have much higher energy. Gamma rays are often emitted along with alpha or beta particles during radioactive decay. They have the shortest wavelengths among the electromagnetic spectrum, with a wavelength no shorter than 0.01 nanometer or 10 picometers. They have the highest frequencies among the electromagnetic spectrum. Gamma frequency is commonly greater than 1019 Hz.
Infrared, sometimes called infrared light, is electromagnetic radiation with wavelengths longer than those of visible light. It is therefore invisible to the human eye. IR is generally understood to encompass wavelengths from around 1 mm to the nominal red edge of the visible spectrum around 700 nanometers. Longer IR waves, 30 to 100 UM, are sometimes included as part of the terahertz radiation range. Almost all black body radiation from objects near room temperature is at infrared wavelengths. As a form of electromagnetic radiation, IR propagates energy and momentum, exerts radiation pressure, and has properties corresponding to both those of a wave and of a particle, the photon. The infrared radiation can promote local blood circulation and reduce muscle tensions. Examples of traditional medical applications of infrared radiation include the relief of muscle pain and tension, as well as the treatment of autoimmune disease or wound healing disorders. Infrared was discovered by Herschel, discovered the existence of infrared light by passing a sunlight through a glass prism in an experiment similar to the one we describe here. As sunlight passed through the prism, it was dispersed into a rainbow of colors called a spectrum.
Microwave. Microwave is a form of electromagnetic radiation with wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300. Function Microwaves are used to detect speeding cars and to send telephone and television communication, and the industry uses microwave to drive. The invention of microwave oven was attributed to the American engineer Percy Spencer, who proved the magnetic effect on products. In conducting his research, he found that waves of a certain frequency emit a large amount of heat. The process of microwave. A microwave oven is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range.
And now we know how important and useful the electromagnetic waves and the contribution of it in our today's world. We also have known who are the people behind these wonderful and useful discoveries, and we should give them the credit and thanking for how they made our lives more easy. Hope we all learned a lot in this video that we can apply or use in the future. Thank you.